Okay, here is the September trial chemistry exam for 2021, which, as you know if you endured this paper, is in fact the November 2020 alternate paper. So here's the multiple choice. Which one of the following is an alkane? So now, if we want to find an alkane, we know that the formula for an alkane is CnH2n plus 2. Okay, so you can use this and just work through all of these to figure out which one is the answer, if you can remember your general formulas. And the answer will be this one, number D, because it's CnH2n plus 2. If you can't remember your general formulas, just go and draw 6 carbons in a row, because can you see these have all got 6 carbons, and then start counting how many hydrogens you would have to put on, because we all know an alkane is completely saturated, and you will find out you've got 14 hydrogens on here, and you will get your answer. Then 1.2, esters are formed by a reaction between two organic compounds, X and Y, each with a different functional group. So if you know anything, you'll know it is an alcohol and a carboxylic acid, okay? And then it says to you, what are the functional groups of these compounds? So an alcohol always has the OH, and the carboxylic acid always has the double bond to the O and then the OH, okay? So what is confusing here is the hydroxide ion is out because it's an ion. There's no ions involved in here. You've got the choice between the carboxyl and the carbonyl group. So the carbonyl is also a C double bonded to an O, but it doesn't have the other O and the H. So it is in fact A with the carboxyl group, because this one is the carbonyl and this one is the carboxyl. Okay, so you just have to learn your functional groups. Then we come to 1.3. When butane is subjected to high temperatures and pressures, the following reaction takes place. This is in fact a cracking reaction, okay? And it says which one of the following represents Y. So you have to use the law of conservation of matter here. You have to say to yourself, the atoms on the left, of which there's only butane, okay, which we know is a 4 carbon, okay? And then how many hydrogens have we got? It's an alkane. So remember that general formula, CnH2n plus 2. So 2 times 4 is 8 plus 2 is 10, gives you C4H10. Goes to methane, which is CH4 plus Y. How do we know what Y is? To figure out what Y is, we have to say, I've got 4 carbons on the left-hand side and 1 on the right. I need another 3 carbons on the right-hand side. I've got 10 carbons on the left-hand side. I've only got 4 on the right, so I must be C3H6. So we can immediately rule out number D, because check, number D's got 4 carbons, and we cannot miraculously produce carbons from nowhere, okay? Now we need to check who has in fact got 6 hydrogens. So 3, 4, 5, 6, 7, 8, 2, 3, 4, 5, 6. It looks to me like this fellow is the answer. So 1.3 is going to be B. You just have to use the law of conservation of matter. Atoms on the left equals atoms on the right. Now look sharp, everybody who's just looking for the answers. This is in fact 1.5, not 1.4, okay? In which one of the following reactions at equilibrium will the yield of the product increase? Okay, so we want the products to increase when the volume of the container is increased at constant temperature. So if we increase the volume of the container, we decrease the pressure. And according to Mr. Le Chatelier, or that dude, whatever his name is, okay, if we decrease the pressure, the system will try to favor the reaction that increases the pressure. Okay, so how do we increase the pressure? We increase the pressure by putting more moles on the right-hand side than the left-hand side. Okay, so, or more moles on, we'll favor the reaction that puts more moles. So in this one we have 1 mole goes to 2 moles. In this one we have 1 hydrogen and 1 iodine, so that's 2 and 2. In this one we have 4 and 2. In this one we have 3 and 2. So the only one that will increase the yield of the product, okay, which is the forward reaction, is A, because 1 mole goes to 2 moles. You should also, if you're not sure, if you know that it's got to do with the moles, if you check this, look here, there are 2 answers here that will have the same pattern, that there's more moles on the left than on the right, okay? Then you know this must be wrong, because they can't put 2 answers that are the same. It's just not okay. So, and this one is same, B, so the answer is A, using logic, if you follow the pattern of the answers. Then we're going to go backwards now to 1.4, okay? So if you were not paying attention, we went 1.3, 1.5, we're now on 1.4. So it says to your hydrochloric acid solution of concentration 1 mole per cubic decimeter is added to excess powdered magnesium at 25 degrees. Curve 1 below represents the volume of hydrogen gas produced during the reaction. Curve 2 was obtained at different conditions using the same volume of hydrochloric acid. So the first thing you do here, volume of hydrogen gas produced against time, this is a rate of reaction graph. And you can see that 1 is slow and 2 is fast. Can you see we end up at the same amount of hydrogen gas produced, okay? So the reaction finishes when the reactants are used up. But what is the main thing? We want to do something in reaction 2 that is going to speed up the reaction. So what can speed up the reaction? Increasing temperature, increasing concentration, adding a catalyst, okay, and the state of division of the what you call it, one of the reactants to increase the surface area for reaction conditions. Now this was powdered, okay, so anything that is a ribbon should actually slow it down, because magnesium comes in that ribbon. So these ribbon factor will make it slower. This will make it faster, okay. Then if we look, we started with a concentration of 1 cubic decimeter. This will make the rate the same. This will make the rate the same. This will make the rate faster. This will make the rate slower, okay. Then we look at the temperature. This one will make the rate the same, the same. This one is a lower temperature, so it will be slower. And this one is a high temperature, so it will be faster, okay. So if we have a look here, these two, which one have got the things that will make it faster? We can rule this one out because we started with powder. The other two are the same and slower. This one is slower, slower, slower. This one has also got a faster, but if you put in the same volume of concentrated acid and there's excess powdered magnesium, this one should produce more gas, okay? So you should end up with the faster reaction and also the curve ending up somewhere else. So then, to me, the correct answer here is D, okay? Because D has got the higher temperature, which will make it go faster. This number B will also make it go faster with a higher concentration of acid, but it can't be making curve 2. So eventually they did say you can accept B in an addendum to the memo in Limpopo, but the fact is it will not produce exactly the same curve, because you should end up with more hydrogen being produced, because the question says there is excess magnesium. But if they let it through, 2 marks to you if you wrote B. But the correct answer is in fact D. Then 1.6. Which one of the following statements is true for an exothermic reaction? Well, if you don't rule out C immediately, that delta H is positive, then you have not been doing your homework. Delta H is always negative, okay? More energy is absorbed than released. No, this makes things go cold when you absorb energy. More energy is released than absorbed. Yes, this looks correct, okay? The energy of the products is greater than the energy of the reactants. No, that is an endothermic, so the answer here is B. Consider the equation below. This is phosphoric acid H3PO4 plus water liquid goes to a hydronium ion, and this first step of what you call this, the ionization of phosphoric acid. I don't know what this hydrogen phosphate ion's proper name is. It's got some name that I don't know what it is. Okay, but now it says to you, which one of the following is a conjugate acid-base pair? To find a conjugate acid-base pair, they have to differ by a proton, okay? You have to have the same substance that's either gained a proton or lost a proton. So it must be a pair, okay? So look here, what happens to water if we gain a proton? We make an hydronium ion. What happens to phosphoric acid if we lose a proton? We make that dude there. And so this is the two conjugate acid-base pairs. So now you have to go look for them in the answer. So the answer is A. You can only differ by the conjugate acid base, by the proton, because that's how you become an acid or a base, depending on your theories, whether you're using the Arrhenius theory or the Bronsted-Lowry theory. You're going to differ by one proton. Consider the balanced, we're on 1.8. Consider the balanced equation for the reaction below. 2Cr2 plus tin 4 plus goes to chromium 3 plus tin 2 plus. The oxidizing agent is, so now my trusty oil rig red cat, any redox must be done with this. Oxidation is loss of electrons, reduction is gain of electrons. So the oxidizing agent is itself reduced. So who has gained electrons? And if you gain electrons, you become more negative, okay? So who has become more negative here? Oxidation is loss, reduction is gain. Let's just think. Who becomes more negative? Am I right here? Let me have a look here. The oxidizing agent is itself reduced. I always get tangled up when I talk about this. So reduction is gain. So who gained electrons? So this was +2, this was +4, this was +3 if we look at the oxidation numbers, and this was +2. So if we go on a number line, yes, and we have 0, and we go from 2 to 3, we're going that way, okay? And if we are on 4 and we go to 2, we are going that way, which is more negative. So who is the person who has been reduced? It is this fellow, tin 4 plus D. Okay, that always takes a bit of thinking. Now, 1.10, 250 kilo bags containing fertilizers R and S respectively are labeled as follows. Yes, I know this is out of the curriculum, but just in case you're curious, this ratio is nitrogen, phosphorus, potassium, and we use nitrogen for leaves, and we use phosphorus for roots. So in order to answer this question, who's got the biggest nitrogen number? That is fertilizer R. So we're looking at these two. Who has got the biggest P number for roots? It is fertilizer S. So this one, 1.10, the answer is C if we want to make leaves and roots. And now finally, we will go to question 1.9 out of order. So it says to you, an electrochemical cell is set up at standard conditions. The cell notation for the cell is given below. Okay, so what do you need to see here? You see there are aqueous solutions. So standard conditions for aqueous solutions is that the concentration must be 1 mole per cubic decimeter, and obviously the gas at 1 atmosphere, and I do believe the temperature at 25, okay? So then we know that it goes anode, bridge, cathode like ABC, yes, because the bridge is the double line. So what happens? We remember oil rig red cat. So the reduction reaction is occurring at the cathode, okay? So what is reduction? Reduction is gain of electrons. So at the cathode, Pb2 plus is going to gain 2 electrons and form Pb metal. And at the anode, where oxidation occurs, the magnesium is going to go to the magnesium ion plus 2 electrons. So it says to you, which one of the graphs shows best represents the concentration of the electrolytes after a long time? So now in the beginning when I read this, after a long time, I assumed they meant at equilibrium, that you've already reached equilibrium. And then I was like, do they mean that, or do they mean over the course of time? Okay, and so in the beginning I thought maybe this one is correct because it is at equilibrium, but check here, the concentration is at 1 mole per cubic decimeter. There's no ways that this cell will reach equilibrium at 1 mole per cubic decimeter. But we do want something with a flat line, because eventually the rate of forward reaction will be equal to the rate of the backward reaction, and they will flatline. Okay, so that's why this one is out and this one is out, this one for the concentration and this one because it never ever levels out. So we need something that has a fast rate of reaction leveling out, and these two, B and C, look similar. But what is in fact going on here? We are making magnesium ions, okay, on this side. We are actually making ions, and on this side we are removing ions because they are going from being an ion to being a metal. So this answer, C, is the correct answer, because you can see here that the magnesium ion concentration increases and the lead ion concentration decreases as the two reactions occur.